welcome back to another video in this week's Java tutorial. So this video is going to be a quick and easy project. We are going to create a factorial calculator. So basically we're going to continue on with our recursion lesson from last time. Remember, last time we created a function that prints out numbers in decreasing orders all the way down to 1. And we learned that method recursion is having the method call itself. And we need to have a good base case, which tells the method when to stop running. So that's basically what we went over last time. This time, our goal is to create a factorial calculator. So if you've ever met factorials in math, then we should understand the concept. So, for example, if you've ever seen a number with an exclamation mark behind it, that's a factorial. So, for example, 4 factorial is 4 times 3 times 2 times 1. And then 5 factorial is 5 times 4 times 3 times 2 times 1. So we can kind of see where we're going here. And we can also see that this is a great example for recursion as well. So we're going to be taking in an integer parameter and then printing out the factorial answer. So a couple of hints is obviously to use recursion. Another hint is to create a placeholder variable. And that placeholder variable is going to start off empty, but then you can assign your answer value to it. And then your base case obviously is going to be x is equal to 1, because when your number is equal to 1, you can just stop because any number multiplied by 1 is the number, right? So let's go ahead and jump right in. It's going to be a little bit confusing at first, but we'll run the code, write the code, make sure it works, and then run it, and then we'll think about it from the compiler's point of view. So again, let's get rid of all this stuff from before. We know that to create functions, we have to write it in the main class, but not in the main function. So static, this time we're going to return an integer, so static int. Factorial, there we go, that's how you spell it, calculator. Then we go int x, so we take in one integer. So like I said, this requires a little bit of thinking beforehand, but we are going to start off by creating an empty integer. So int answer, and we're not going to give it any value. So right now it has no value, we're just leaving it there. What we're going to do later on is our answer is going to be assigned to this variable. So then we're going to say if x is greater than 1. We're going to do basically answer. The answer is now going to be x multiplied by factorial calculator of x minus 1. So why is this the case? If x is greater than 1, so if x is 2, 3, 4, 5, anything like that, we're going to set our answer to be that same number multiplied by the factorial of 1 less than it, right? Because think about it. 4 factorial is just 4 multiplied by 3 factorial. Likewise, 5 factorial is just 5 multiplied by 4 factorial. So that's what I'm saying here. I'm saying any factorial is the number multiplied by the factorial of 1 less than the same number. Then I'm going to say else. So the else in this case, the only other thing is when x is equal to 1. So in this case, else is x equal to 1. That is implied. We would say answer, I can't spell, answer is equal to 1. Why? Because when x is equal to 1, well, then the factorial of 1, well, not the factorial of 1, but like whenever you multiply anything, when your x gets to be 1, then your answer is going to be 1, right? So then after that, finally, we're just going to return our answer. So this was confusing, I understand, but let's go ahead, run the code, make sure it works, and then we'll walk through the logic from the compiler's point of view. So let's do factorial calculator. Let's do an easy one. Let's do 4, because we know that 4 is 4 times 3 factorial. Similarly, 3 is 3 times 2 factorial. And then 2 is 2 times 1, and that is 2. So then we multiply 2 by 3, which is 6. Then we multiply 6 by 4, which is 24. So this should give us 24. Let's run our code. And we are going to get, oh, sorry guys, I keep on making this mistake, but remember that whenever you return something, you always have to assign that to a variable. So int num is equal to factorial calculator 4. Then system.out.println num. Because remember that this is returning an integer, and then we save that integer in our variable, and then we print that variable out. So when we print it out, we get, oh no, we get an error. Why do we get an error? Oh wait, no we don't. We get 24 down here. Hold on. Let me run this again just to make sure that everything was going right. There we go. Because if you remember in our past video when we were doing the basic recursion and I showed you an example of Stack Overflow and then this happened, right? That's what it's from. But we know that the answer is correct. It's 24, which means that our function here works. So let's go ahead and explain this function. So we start off and our integer passed in here is 4. So answer currently has no value. So if x is greater than 1, is 4 greater than 1? Yes. So then the answer is 4 multiplied by factorial calculator of 3. Now, in order to find that, we're going to have to pass in x this time as 3. So is 3 greater than 1? Yes. So the answer now is 3 multiplied by the factorial value of 2. So now x is 2. Is 2 greater than 1? Yes. So now 2 answer is equal to 2 multiplied by factorial of 1. So now that x is 1. But since x is 1, is 1 greater than 1? No. So does this if statement work? No, it doesn't. So it goes to else. So now the answer is 1. So since the answer is 1, we've gotten to the bottom. Now we can multiply everything. We multiplied 1 by 2, remember, because remember 2 times 1 is 2. Then, since this value originally when x is 2 was 2, we multiplied that by 3 because at that point x was 3. So then when 2 times 3 is 6, we remembered that the factorial value of 3 was 6 and then x was 4, so 4 times 6 is 24. So basically what I'm doing, guys, and I'll write this in a comment, is I'm going down the ladder when running the function, and once I meet my base case, I multiply going back up the ladder. Because remember, we started from x was equal to 4, and then we went down to 3, 2, 1. But once we found out what the value was for 1, we went back up the ladder, and we multiplied 1 by the factorial value of 2, by the factorial value of 3, 4, and then we went from down, and then we climbed back up the ladder, right? So this was slightly confusing, I understand. What I think I'm going to do is I'm going to run through this one more time with 5 as an example, and then hopefully by then we'll understand. So we run our code and it gives us 120. So let's think about it. First we're going to go down the ladder. So int x is 5. 5 is greater than 1, so answer would be 5 times factorial of 4. Now factorial of 4 means we have to run this function again. So now 4 is greater than 1, so then the answer is 4 times factorial of 3. 3 is greater than 1, answer is 3 times factorial of 2. 2 is greater than 1, answer is 2 times factorial of 1. So x is 1. So the answer is 1. But then once we got the answer, we have to go back up the ladder. So we do 2 times factorial of 1, which is 1, so we get 2. Then we get 3 times factorial of 2, which is 2. Then we get 4 times the factorial of 3, which is 6. Then we get 5 times the factorial of 4, which is 24. So we went up the ladder, we went down the ladder, then we went back up the ladder. This was a hard example of recursion, especially in our factorial example. I get it, it was pretty confusing. Go back, watch the explanation a few more times, try to run it on your own. My idea of going up and down the ladder may not be the breakthrough for you, but it works for me and it works for some people, and try your best to really understand it from your own point of view and find a way to think about it that makes the most sense to you. So I'll leave you guys on that note, And the next video is going to be super short and sweet about some important Java string methods. So that's it for this video. I'll see you guys for one more. Bye, guys.